Let's have a look at the Module 5 test review. So remember our congruency test: side, 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 angle, side, angle, side, angle, 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 side, and only when dealing with right triangles, we have hypotenuse leg. Remember that angle, angle, angle is not a valid test, nor is the situation where you have two sides and then the angle, I'll place it there. Okay, neither of those actually work. So writing the congruency statement, so in this case I can see that all three pairs of sides are congruent, all three pairs of angles are congruent. If you're going to write y first, notice that y is marked with the 3 markings, so I'll need to come up with p over here in the other triangle. W has the double markings on the angle, so that's going to correspond with Q. Just want to line up the corresponding parts. So do we know if these two triangles are congruent? Well, we have a pair of angles, we have a pair of angles, a pair of angles, and a pair of angles. Yes, it's a right triangle, but I know nothing about any of the side links. This would be angle, 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 and that is not a valid congruency test. In this case, if this is a right angle, you know that these two make a linear pair, so this has to be a right angle. So these two triangles each have a 90-degree angle. We know those are congruent. That's an A. They share this side, so that's going to be congruent in both triangles. That's a side. And then we have another pair of angles marked congruent. So these are going to be congruent by angle included side angle, the side between the two angles. All right, in number 4, the two triangles do share this third side. So I have 3 sides in one triangle congruent to 3 sides in another. They're congruent by side, side, side. In this particular case, we have a pair of angles, that's an A. And then as I move along the triangle, I have another pair of angles, that's another A. And they share this side. Unlike this one where the side fell between the two angles, here are my two angles and then my side. So these are congruent by angle, angle, non-included side. These two triangles share this side by the reflexive property. It's going to be congruent to itself. We see that a lot. So we have a pair of sides congruent, a pair of angles congruent. So in this triangle, I've got a side, an angle, and as I continue walking along that triangle, another side. The angle falls between the two sides, so this is side, angle, side. What additional information would we need in order for the triangles to be congruent by the given test? So in this case, we have a pair of angles. That takes care of our A. And we have a pair of shared sides. That takes care of an S. So zooming in on a single triangle, I want it to be side, angle, side. I want this angle to be where the two marked sides connect. The angle is the vertex where those sides join. So this would need to be the third side in this triangle. And in this triangle, again, I want the two sides to connect to make the angle. So it would need to be side KX, segment KX would need to be congruent to segment WV. In order for these to be congruent by angle, side, angle, we want the side to fall in between the two angles, in between the two angles. We have a pair of angles and we have a second pair of angles. We just need that side. So we need for QR to be congruent to TS. For angle, angle, side, we need 2 pairs of angles. We already have a pair of sides in each triangle, and we also know, they don't have to give us this, we know that the vertical angles are congruent, so that's a pair of angles. And then this time, we want these, I don't know why I marked that, sorry. We want these 2 sides. Well, in a single triangle, we don't want the side to fall in between the 2 angles. It needs to be angle, angle, and a non-included side. So I wouldn't choose this angle because then the side would be between them. That's only going to leave this one and this one. So I have an angle, and then the side, an angle, and then the side. So it was those 2. We need for angle U to be congruent to angle E. All right, now we're moving on to the triangles and what we know about the sums of the angles. 152 is an exterior angle. It's an extension of one of the sides, and it does make a linear pair. You could certainly use the fact that they add up to 180 and find that angle and then just move inside the triangle. But the exterior angle is equal to these two angles added together. 85 plus x is equal to 152. So we just need to subtract 85 from both sides in order to come up with the measure of that missing angle. And subtracting 85 from both sides, you're going to end up with 67 for x. Same thing here, we extended the side, and this angle is making a linear pair with that one. That makes that an exterior angle, and the exterior angle is equal to the two remote interiors added together. So we just want to add those up, and x is equal to 45. And again, you could have just added these two, subtracted from 180 and find that angle, and then use the fact that they make a linear pair. All right, so looking at our congruency statement, we want to write down what we know. Do we know the value of ST? Well, S and T are the first two letters, and since the triangles are congruent, it'll have the same value as PQ, which is 7 meters. I'm not going to put the units, but SU, S and U are the first and third letters. They're going to be equivalent with P segment PR, which is 8. The measure of angle R is the last one, so it matches up with U, and I don't know U. So let's just deal with the angles for a minute. I do know P is 59, and I know that P and S are congruent. So let me come over here and say that S is 59. And then I can add the 75 and the 59 and subtract that from 180, since the angles in a triangle add up to 180. And that's going to leave us with 46 for U. And U is congruent to R, so R is 46. And T, the middle letter, is congruent to Q. T is 75, so Q is 75. So the measure of R was 46, the measure of Q was 75, and the measure of S was 59, just matching up parts. Okay, select anything that's valid. All right, so looking at how this is marked, since the angles are marked, we can focus on those. H is marked with 3 tick marks, so is R. G is marked with 2 tick marks, so is T. And F and S are both marked with a single tick mark. So F is not congruent to R, it's congruent to S. Not that one. Is G congruent to T? Yes. What about GH? So we're going from, well, this side is marked with double tick marks. GH and TR also marked with double tick marks. That's correct. What about segment ST? ST is congruent to FG, not HF. And then let's just look at the order of the letters. So they're going GHF, which is the way I marked it. It's the box to the circle to the arrow. That needs to be congruent to the box, the circle to the arrow, TRS, which is what this one says. And then what about HGF? So we're going the other way. We're going from the circle to the box to the arrow. So it needs to be the circle to the box to the arrow, which should be RTS, which is not the case there. All right, in any triangle, the angles add up to 180. So we just want to add these two. That adds up to 113 and subtract that from 180. And that's going to leave us with 67 degrees for our missing angle there. In this triangle, all 3 angles have to total 180, but this one is 90 all by itself. So remember, these two have to add up to 90 together, plus an additional 90 will give us 180. So if we add these 2 angles together, that should equal 90. 7x minus 3 plus 3x plus 3 should equal 90. Let's work on the left side of the equation first. We're not canceling things, we're grouping up like terms. 7x and 3x, we have a total of 10x, and the minus 3 and the plus 3 is just going to zero out. So 10x equals 90, Divide both sides by 10, and x is equal to 9. And we're solving for x each time. Okay, so in this triangle, all three of these angles need to add up to 180. So 8x plus the bottom right, 13x plus 5, plus 70, the three angles need to equal 180. Same thing, I'm gonna, on the left side, I'm not canceling, I'm grouping up like terms. 8x and 13x is 21x, 5 and 70 is 75, and that equals 180. Subtract 75 from both sides, and we'll get that 21x equals 105. Divide both sides by 21, and you end up with 5 for x. Okay, and number 17, still solving for x, you should notice that we have a pair of congruent angles. That makes this the base, and it makes these two sides the legs. This is an isosceles triangle. So those two sides are equal in measure, so I can set the 8x plus 18 equal to 8. Now we're solving for x, we're not finding a side length. I am going to get a negative number here. X is equal to negative 10. But if you plug negative 10 in here, this does give you 8, and that's how long that side is. So that checks. All right, same thing. We have an isosceles triangle, and where the two legs connect, remember, this is our vertex angle. That makes these two angles down here, this is the base, those are our base angles, and they're congruent. So subtract 40 from 180, that's going to leave us with 140, and then that needs to be split into two equal pieces so that each of these pieces are 70. X is 70. X equals 70. Okay, all right, same thing here. It's an isosceles triangle. This is the vertex angle. So since that's the vertex angle and these are the legs, these are my two congruent base angles. This angle is forming a linear pair with 110. Right, they lie along that line. So this one has to be 70 because together those two should add up to 180. So this one is 70 as well. And all three of these inside the triangle need to add up to 180. So 70 plus 70, 140 plus the x should equal 180. Subtract 140 from both sides and we'll get that x is 40. Okay, same thing here. Let's see where we need to go. I think we're going to have to make our way to this right angle here. In this isosceles triangle, these are the two base angles. So this one is also 71. If you add 71 and 71, you get 142. We need to subtract that from 180. That's going to leave us with 38 here. These two angles are complementary. They need to add up to 90 together. So this one needs to be 52 degrees. And now when I make it over to this triangle, 52 is the vertex angle where the two legs connect. So this is the base of this triangle, and these two angles are congruent down here. So I need to subtract 52 from 180. And that's going to leave me with 128, excuse me. 128, which I'm going to cut in half. 128 divided by 2 will give us 64 for each of these two angles. And then x is outside the triangle. It's making a linear pair with 64. So subtract 64 from 180. And so 64 gets subtracted from 180 in order to find x. And that's going to leave us with 116 for x. Okay, the perimeter of TUV. Perimeter, of course, is the sum of the sides. The distance around is 95. Are the two triangles congruent to one another? All right. Let's go ahead and just add up the three sides. So we have 2x minus 10 plus x plus 25 plus x, and that should equal the total distance around the triangle, which is 95. Again, just grouping up like terms, 2x, 1x, and 1x. I have a total of 4 x's. A minus 10 and a positive 25 will be plus 15. Subtract 15 from both sides, and we get that 4x equals 80. Divide both sides by 4, and x is equal to 20. So this side is 20, this side is 45, and this side, 2 times 20 is 40 minus 10, or 30. Are the triangles congruent? Well, the only thing I know about triangle WXV is I know the length of VW right now. And V and W are the first and third letters. It's 40. If they're congruent, the corresponding side, which in this triangle is TV, has to be congruent, but we can see that the measure of side TV is 45. So TV does not equal VW, so no, the triangles are not congruent. All right, we have a flowchart proof down here. So in our given, D is congruent to F. That's already been marked for us and written, so we knew that because it was given. The next given statement hasn't shown up in the proof yet, but the reason for what we put in this box is given, so that's going to be the second part of the given. Segment GE bisects angle DEF. So this is acting as the scissors. It's doing the cutting. This is getting cut it's getting cut into 2 equal pieces. Okay, this does the cutting. So segment GE is here, and it's cutting angle DEF, which is this one. So this whole entire angle is going to get cut by this segment into 2 pieces. So this part of the angle is now equal to that part of the angle. That's how we mark it. Well, the name of this top angle is angle DEG. Angle DEG is congruent to this bottom angle is FEG, angle FEG. And I know that because that angle was bisected, and that's what it means to bisect something, to cut it into 2 equal parts. So this is definition of bisects. All right, now notice that these 2 statements are leading into my congruent triangle statement, and we know that it takes 3 parts to prove triangles congruent unless we're dealing with right triangles, which we aren't. So this is a pair of angles. This is another pair of angles. We know we need another part. And look, we've got a segment. And we're saying that GE is congruent to, well, GE is going to be congruent to itself. That's really the only thing we can get on our own here. We know that for sure because of the reflexive property. So if you look at a single triangle, we've marked 2 angles and a side, and the side is not in between the angles. So this is angle, angle, and then the side. These triangles are congruent by angle, angle, side. Let's be sure we match up the parts. So D was congruent to F, so it's triangle F. E is congruent to E in the other triangle, and then G. Okay. All right, so actually we haven't done this yet. So once triangles are congruent, all the other parts that match up are also congruent, right? That's what it means to be congruent. So DG, which is this side, is congruent to FG. Do those correspond? DG, first and last letters, FG, the first and last letters. Yeah, those are the corresponding parts. So once you have congruent triangles, all of the corresponding parts are going to be congruent to each other. And there's an abbreviation for that, and it's that the corresponding parts of congruent triangles are congruent. It's CPCTC. Don't worry about that for the test, however. We hadn't covered that yet. All right. I feel like I've done this question. It is an awful lot like this one. So we're starting with a 72-degree angle. This triangle is isosceles, and this is the base of that triangle. So that's my other congruent base angle. 72 plus 72 is 144. Subtract 144 from 180, and that's going to leave us with 36 degrees there. This angle is complementary with this one, since together they have to add up to 90. In order for that to work, this would need to be 54 degrees. And now that I'm in this triangle, it's also isosceles. These are the two legs, so this is the base. That makes this the other base angle, and the base angles are always equal. So now in order to find the vertex angle, I just need to add these two together. They add up to 108, and subtract that from 180, and that's going to leave us with 72 for x. X is this angle here in this triangle. All right, very similar, kind of doing the same thing over and over again. Here's an isosceles triangle. If those are the two legs, then this is the base. So these are the two base angles. That's also 74. If you add 74 and 74, you get 148, which we need to subtract from 180. And when we do that, that's going to leave us with 32 right there. And that's vertical with this one. So this is 32. And now when we make our way over to this triangle, it's also isosceles, and these are the two legs. So this is the vertex angle. That makes this the base. So these are my two base angles down here. So if this one is 32, so is x. All right, finally, in number 25, let's start where we have an angle measure of 60. An isosceles triangle, that's the vertex. That makes this the base. So these two angles have to be congruent. This one is also 60. We're trying to find x. X is this angle. We'll notice the right angle there. So 60 and x need to add up to 90. That means x needs to be 30.